This is Hart Hagan with Soil4Climate, and I'm here with Tony Saladino. Tony, how are you doing today?
I'm doing great, thank you.
We're going to talk about biochar. So, Tony, tell us what biochar is and how you got interested in it. But first, let me say, Tony is with Eco Tours of Wisconsin. Tony's a biochar educator. And so, back to the original question, Tony, how did you get interested in biochar and what is it?
Well, biochar, my brother-in-law likes to call it super soil. It's a matrix of carbon that looks like a whole bunch of tiny little tubules, and it provides massive habitat for the soil microbe. What really got me interested in biochar to begin with was my lifelong interest in ecology uh, and environmental ethics. And I discovered it through readings of archaeology. It's old literature that had almost been forgotten. And as soon as I read about it, I knew I had to start experimenting, making my own, experimenting with different formulations and combinations. And I've been doing that for over 12 years now, teaching others to do it. Biochar is actually very simple to make, and science now knows we've been making it as human beings for over 9,000 years. Basically, you just heat up wood in the absence of oxygen, and that process is called pyrolysis. It releases about half the energy that's stored in the wood, primarily as hydrogen and oxygen, which is flammable gas.
Hmm.
Once the flammable gas stops coming off, you can either quench it with water or starve the retort, the heating vessel of oxygen, and let it cool. The material actually glows. It gets so hot that it glows between 500 and 600 degrees centigrade. Uh, and it's transformed just like clay becomes a coffee mug or a plate. Uh, it turns to stone that the only ingredient is carbon. And then there's a process you go through. It's actually five more steps. You have to add nutrients, soil precursors, microbes, and then let it mature. That maturation process is done at a specific moisture content. So the microbes are happy. Uh, and once you have a thriving microbial community living on all that surface area, it does all kinds of great things for agriculture, gardeners, uh, carbon sequestration. Uh, and I'd like to talk a little bit more about, all the steps that are required uh, to make super soil.
Mhm.
It's an amazing product.
So we met in Soil4Climate, which is a group that, it's like, how can we be good to our soils so that our soils are good for climate? And biochar can play a role in that. Is that right?
It definitely can. When I started out as an organic gardener uh, ages ago now, uh, everybody talked about compost, compost, compost. And that's only half the picture. Uh, if you are a bodybuilder, you've heard of anabolic and catabolic processes. One, you're breaking down material, the other, you're building it up. Compost is only half, it's the breaking down of existing organic material. And from root exudates, scientists are finding that the plants can actually pump carbon into the soil through their roots.
Hmm.
And that's the anabolic process, just like a muscle bodybuilder building mass. So we can build the carbon either through adding massive amounts of compost or these root exudates. And the biggest difference is with the root exudates, it feeds organisms, the soil microbiology, fungal hyphae, the root hairs themselves. The catabolic process of composting is degrading the carbon structures, and about 90% of that carbon goes back into the air or turns into a critter. A bird eats a worm and it flies away. So you have all these routes for carbon to leave the soil or get it back into something else. About 10% turns into humate, and that's more stable in the soil because after the carbon has been through several organisms' digestive tract, there's not a lot of nutrient value left, but it adds structure to the soil. What the biochar does is it adds the structure in a way that does not break down. So it's kind of like a third way. It's the third place for us to store carbon. We could do massive composting, but that has a limit because of time. We could add the root exudates, which also feeds organisms, and they have a finite lifespan as well. But that's going to build humic material as well.
So what
Um,
I'm hearing you saying is that biochar is a quicker way of doing what we want to do, what we've been trying to do by other means. So we want to reduce carbon by reducing emissions. We also want to sequester or store carbon in plant matter, in the soil, etc. So one thing I hear you saying is that biochar is a quicker means to those ends, and it's not in conflict with those other things. Like if you have biochar in the soil, it's going to be good for your soil organisms. It's going to be good for your plant matter. So your plant matter is pushing more carbon into the soil by those root exudates, et cetera. So you're saying that this is a win-win-win-win-win all around. There's really no downside. Am I right on that?
Absolutely. Uh, it's interesting because it's kind of like principle and interest. The principle is the massive amount of carbon that's in living tissue. The interest is being able to store that over a long time. And the carbon, once it's made into biochar, is like a sponge. So it will hold more life, it will hold the nutrients, it will hold additional carbon on all the surfaces and in the pores. So it kind of gives you a longer residence time.
Mhm.
If you're fertilizing with organic fertilizers, you only have to do it half as often. So I was on an aggressive schedule of composting heavily every 3 years in my gardens. You turn that into every 6 years, and all of a sudden, you have either you can double the acreage that you spread your compost on, or you can just take the afternoon off and not work,
Right.
not work that day. So it actually opens up options. Uh, if you're only having to irrigate half as much, all of a sudden your time budget gets a boost,
Mhm.
and you can focus on maybe starting some more tender plants that need a little more care, or again, expanding your uh, acreage, or investing in something else,
Well,
uh,
one thing that's surprising to me is that, usually when you burn something, then carbon is emitted. Carbon
definitely.
dioxide and carbon monoxide, maybe other forms of carbon, are a byproduct of the incineration process. But you're saying that because this is an anaerobic process, well, when the wood is heated, it's deprived of oxygen.
Yes.
Somehow that results in a situation where the carbon is retained in what becomes biochar.
Hmm.
And also, you're saying that hydrogen and oxygen are byproducts of this process. So you're not putting more carbon into the atmosphere when you do this.
Right. The caveat to that is you do have to heat the material up. And the most common ways of doing that we have available is through carbon intensive sources. So
Right.
I use a pretty primitive process. I use a bonfire in the backyard. That fire itself does have some emissions of carbon,
Hmm.
but uh, it would be as if every time you filled your gas tank, it stayed half full. So we are burning carbon
Yeah.
to keep half of the original material forever.
Mm.
So it kind of changes the equation. We're not just blasting everything into the air. And most biochar retorts or kilns have very, very low emissions.
Mm.
the goal is to keep hold of the carbon. And the only way plants store energy is through carbohydrate. And when you drive off the hydrogen and oxygen, all that's left is carbon. So it works at cross purposes to blow that carbon off into the air.
So you're saying that there's something called a retort, which is kind of like a kiln. So I'm asking what kind of container you need. So if you get the container and then you heat it up, then you can do this process. You find wood and that kind of thing. You can do this process. So what kind of container are we talking about?
Well, the first time I ever saw this done was a complete accident. Uh, it was in a cast iron uh, skillet with a lid. No air could get into it, but it charred the food inside. We basically had a house fire, but it stayed inside the pot because no air could get in there. Everything just charred. And you can start as small as a cookie or cracker tin. You basically want to fill it with dry woody material, screw the lid on. I usually use self-tapping screws in a few places because it will generate pressure inside the container as the material heats. Then you poke a few holes in the top so that that pressure can release without blowing the lid off. And that'll give you enough of an airtight container. Then you just put it in your fire pit. The next time you have a bonfire, or say you have leftover coals after you cook a barbecue, just throw it in that hot space. The gases will start coming out and ignite because it is the hydrogen and oxygen. And once those flames don't come out anymore, I usually shake it around to make sure it's thoroughly heated inside the vessel. Once you don't have flaming gases coming out anymore, turn it upside down on a flat surface and let it cool. It takes a long time to cool usually. I usually leave it out overnight because the char will reignite if you let oxygen get to it while it's still hot.
Mm-hmm. Hmm.
And that's the basic, that's the starting point, making char. And a lot of the,
How do you know that you've gotten it hot enough or you've cooked it long enough?
once the gases stop coming out, there's no reason to continue heating it. You're basically trying to break down all the lignin structures, everything that's part of the carbohydrate that's not carbon is going to go away readily by the heating. And once
So the
those,
gases stop coming out of the holes you've punched in the container.
yep, yep, and you can see the flame, so it's not difficult to tell when it stops.
Mm-hmm.
You won't get any smoke or, if anything, at the very beginning when you put it on, there will be just a minute or two of smoke that comes out. But once those gases ignite, it burns super clean, and there's virtually no smoke at all.
So you're a gardener. Have you seen better results from from the plants that you've grown with biochar than without?
Absolutely. The first 5 or 6 times I tried it, I almost didn't believe how successful the changes were. I did very small controlled plots where I would mix the same soil mix and then only add char to one. And after the first couple of times, I've gotten to the point where I won't plant a plant or a seed or a tree seedling unless I've amended the soil with the char because the results are so dramatic. I live near the 45th parallel up in Green Bay, Wisconsin, and we get a full month of extra growing season simply by having the char in the ground because the microorganism community is so vibrant and so flourishing. You don't think of a microbe as having metabolism, but they definitely do. We're big, you can measure our body heat quite easily, but uh, in every uh, in every acre of soil, if you can raise the organic material in the soil, the microbial community will respond as well.
So that's amazing. So what you're saying is that, most of us here in North America have a winter,
Mhm.
and you can shorten the winter and lengthen your growing season through biochar. And the reason for that is the metabolism of the microorganisms. Just the same way we produce body heat, microorganisms produce body heat
Yep,
and heat up the soil and make it, lengthen your growing season.
they do that for sure. They're just like us. I mean, we can't see them, but they're just like us. About 70% of their body weight is moisture. So even in the microbial community, it's like a battery for moisture. And what do we know about water? It holds energy, it holds
It
heat.
holds energy very well. Water
Yes,
holds energy better than just about any substance.
absolutely. Absolutely. And I think one of the things that I wanted to kind of focus on is some of the benefits. I've actually recorded double, sometimes more than double, the biomass created on soils that have only 1% biochar. So if you measure by weight, uh, the char itself is very light. The, the char material that you create with the process I described will hold 6 times its weight in water. So it is very much like a sponge, except we think of sponges as being flexible. This sponge is rigid and it's made up of millions of tiny tubes. So those tubes can fill with water. When they dry out, they're still full of air. And the microbial community needs both air and water to thrive. So you're creating the perfect habitat.
So you can measure the biomass. So when you amend your soil with biochar, then it's going to hold more water, and you can measure that, and it's going to hold more biomass, and you can measure that. You can measure the biomass in the soil.
Yes. Uh, there are some really cool devices you can use now that will give you uh, microbe content, microbe population density, so to speak. Uh, and I haven't sprung for those yet. A lot of them go through your cell phone through an app to measure. And I'm still so primitive. I let my wife have the cell phone. I don't really take that link to the digital world with me wherever I go yet. I'm sure that'll change soon.
So you're saying there are a soil, is it a soil test or is it a device? Do you have to send
It,
off a soil sample, or is there a device or an app
no,
that you can
it
use to measure the biomass?
it's a unit that you can put into the soil, and it'll tell you uh, readings of all different parameters. And I believe there's one. It's fairly new, within the past year or two, where it'll actually tell you the microbial population, the density of microbes per cubic centimeter, or I suppose you can change the
Mhm.
scale depending on what you want to see.
So we know that if there are more microbes in the soil, that is an indicator of a whole soil ecosystem. So if you will, a soil ecosystem starts when you have a plant root exuding those exudates, which is the sugars that then the microbes consume, and then that attracts fungi, and then you have your multicellular invertebrates like worms and insects and millipedes, centipedes,
Yep.
grubs, so
Yep.
a lot of probably larvae of
Things we
insects.
can see. Yeah.
Yeah.
It builds up. Um, yeah. And this habitat, the goal as an agriculturalist is to create the most stable system of organisms in the soil, because their waste products are what directly feed the roots.
Right.
And we even have some microbes that inhabit the inside portion of roots. Some exist on the surface and only penetrate slightly into the root. And then we have ones that live completely outside the root that are dependent on the exudate. So Uh, I think when I looked at just the largest uh, factions in the soil, the main species, there were over 20 different organisms that are typically found in healthy soil. And what we find from work with people like Gabe Brown is the more members you have in a community, the more stable it gets. Uh, Similar to what we see as humans, a healthy town has uh, every resource you need in the town. The reason towns get unhealthy and depression and economic squalor come about is because you don't have all the constituents of a healthy community. Uh,
Tony, this has been excellent. We want to save some for next time. Let's just say, how can people get in touch with you if they want to learn more about you? And then once you share with that, we will revisit this on another time.
Great. I have blogs that are out there. Eco Tours of Wisconsin is one of them. That's at Blogger. And I also have email if people want to contact me directly. T as in Tony, N as in Nancy, Saladino, like salad, INO, 42 at hotmail.com.
So it's tnsaladino42@hotmail.com.
That's correct. Yep.
And your blog is
Eco Tours of Wisconsin,
Ecotours of Wisconsin at
Blogger. Yep.
blogger.com.
Yep.
Okay,
Absolutely.
great. Well, thank you so much for joining me. We're going to come back really soon and talk about biochar. It sounds like there's a lot of benefits and advantages to using biochar. It sounds like it can complement everything else we're trying to do with
Absolutely.
sequestering carbon and storing water and growing healthy plants and cleaning up our waterways and having a healthy, thriving soil ecosystem. So, Tony, thanks so much for joining me. Let's talk again soon.
Thanks for having me. We definitely talk again.
Yeah.
Bye bye.